Okay, thank you. And yeah, thank you everyone for being here. This is the first time we've tried this, so hopefully it goes off without a hitch and we all get something out of it. So again, my name is Mark Druin. I am an underground storage tank inspector for the state of Oregon. And we're basically today going to talk about part of the testing that's all the operators are required to do. We see out in the field some communication issues, so we just want to kind of convey of what we're looking for on one piece of the testing, and I'll get into that in greater detail. So just quickly, so you know what's happening today, I'll talk probably about 30 minutes. We'll introduce our testing form. I want to give a little history of the countrywide, statewide UST program, and then Oregon's UST program, introduce the inspectors. We've had new inspectors join the program, so I just want to introduce everybody. And then as that'll go for about 30-35 minutes, and then as we switch over to Kevin, we'll take a few seconds to see if we have any questions. Lauren Dimmick and the other inspectors will help facilitate these questions. So please type in the questions and where we're capturing them, and if we can't get to them, we'll answer them later. And not, we can only see them, so not your competitor or somebody else can see them. And I also want to let you know that this presentation is going to be posted online because there are some live links that you may be interested in later on down the road. So again, quickly we'll go through a little history and introduction. So again, my name is Mark Druin. I've been with the agency for about like 8.5, 9 years, the whole time as an underground storage tank inspector. And for a few years, I was out of the Bend office, and now I'm up in Portland. We also have Ingrid Gaffney. She has been with the agency about the same amount of time, about 9 years. And she comes with us with some great heating oil tank experience, air quality inspection, open burn, a whole various array of inspection experience. So we're excited to have her. Dylan Eckert, as some of you have met, he's more of our technical expert. He's an electrician by trade, so he really gets into the manuals and how stuff works. So we really appreciate having him on board. And then Andrea Garcia, I think she's our most senior tank inspector at this point. She's been with the agency at 10, 11 years. And so, but she also has this great inspecting experience out of Texas, where she was an underground storage tank inspector, health inspector, and various others. So she comes to us with really amazing inspection experience. And Lauren Dimmick, who's on the call with us now, she's fielding questions. She's the only one actually in the field who does work, but she also has some great experience with the fish and wildlife. So we appreciate her in tank. So again, we're the statewide underground storage tank inspectors. And for some of you who maybe had facilities for a while, you probably remember some old retired names like Bob McCoy, Greg Turan, Eric Clough, Harrington Rose, Jim Parr, and then in Eastern Oregon, we had Tracy England, who covered that area for about 10 years. But this is currently who you'll see out in the field. We also have people behind us, our manager, Mike Kortnoff, he's always helping us. Then, of course, we have policy with Diana Foss and technical expertise with Dave Pardue and a whole bunch of people behind us. So it's not just us, we do have a team. And one thing I just wanted to highlight, because sometimes I think people may forget, when we're out there inspecting, we're mentioning compliance deadlines and equipment, we're always referencing these rules. These are our underground storage tank rules. They're online, please take a look at them. But so we're not just saying random stuff, we are trying to reference our actual rules. So to put it a little bit into perspective, what us five do, here's one way to look at it. So this is the state of Oregon, obviously, right? And we inspect regulated underground storage tanks. Mostly it's gas stations. So if you see a gas station, we will inspect that facility, but there could be other facilities. We have emergency generators and maybe a couple of farm tanks. And we have tanks like all over the state, from Brookings up to Warrington, to Joseph, to Ontario, to Jordan Valley, Burns, Lakeview, and all the way in between. So there's 5 of us inspecting all these facilities, right? We have about 1,700 facilities, and so we're out there expecting them, trying to get out there every 3 years. And how we used to be set up, the agency still is, and how our program used to be set up is we were more broken up into regions. So we would have a Northwest region inspectors. They would just handle this area, and then a Western region, and then an Eastern region. And what we've moved to is more of a statewide model, where we will move, all the inspectors will move across the state, and hopefully you have experience with us all, and you get more consistently, and you have communication with all five of us instead of just one inspector. And just in comparison, every state does it differently. I always thought this was interesting. In California, our neighbor to the south, they're LA County. They also have about 1,700 regulated facilities, but they have 30 inspectors covering that area. So you may think, well, there's too many of us or not enough, I don't know, but just understand that each state does it a little differently. California is a little unique in there, but they have a bunch of inspectors. So I do want to briefly talk about this. I want to give you a quick history of why we're all sitting here today. And this is, the EPA has this great website. Please download this presentation and check it out. And it goes into greater detail of the history of the tanks program. But we're sitting here today as a direct line of this 1983 national story. It's a news story. It's about 15 minutes long, and it talks about contamination from leaking underground storage tanks impacting drinking water. Big story in the day. And in response to that story, in 1985, the EPA came up with the underground storage tank program. And then 3 years after that, they came up with their first underground storage tank rule. This was a big move for the agency. This is when a lot of tanks started to be removed and a lot of stuff started to happen. And since 1985, there's been updates to these rules and new testing requirements and stuff like that, which is explained in greater detail on their website. But I want to highlight a couple of things. So in 2005, Congress passed the Clean Energy Act. And in this act, it specifically calls out that every regulated underground storage tank needs to be inspected every 3 years. That's across the country. And that's why we're showing up to your facilities to do these inspections as a direct result of this Clean Energy Act. So after this, in 2006, we formulated or finalized our program, updated our rules. I think previous to 2006, we were inspecting like every 5 years, but starting in 2006, we had to do it every 3 years. So that's when Greg and a lot of the retired inspectors came on board and started kind of generating the program. And then in 2015, what happened was the EPA again updated their rules, and they cleaned up some language, they cleared some stuff up, and then they included some more testing requirements, basically spill bucket testing, overfill testing, and a few other things. And in response to that, 2018, we updated our rules to include those same testing requirements with this effective testing date of October 1st. And that's what brings us here today. I just want to talk about one component of this. There seems to be some confusion, and we're just trying to communicate with the regulated community what we're looking for and why. So again, prior to 2020, for some of you operators, you probably felt the inspections were a lot simpler. All you really needed to do was line testing and leak detector testing. And then if you had a steel tank, you would do cathodic testing, and we have a few tanks with tank linings that you'd have to inspect those. So we would show up and it seemed like the inspections would go by relatively quickly. And then starting in October 2020, all of a sudden you're required to do much more testing, right? Spill bucket testing, overfill. Now there's the monthly walkthroughs, maybe some containment sump testing if you're doing interstitial monitoring of your lines. And then the big one here, which we're talking about today, I think it's big, is this annual release detection operability testing, which is a mouthful, but that's how it's defined in our rules. And some of you may see this on your testing documentation as was a tank gauge certification or something. And that's great that it says that, but that's not really what we want done. And so we're going to explain more of what we want for the testing. So a different way to highlight of what's going on today. As an operator, you're responsible for your monthly walkthroughs. You check your release detection and your spill buckets. Now you have your annual testing, which includes this release detection operability testing. But now you also have your spill bucket and overfill and other testing. But again, we're just going to talk about this one component of it. I know there's a lot of testing, and we're only talking about one. And I do want to highlight this document from the EPA. It's on their website. There's the link. It's a great document they came out with in 2015. It talks about the rule update. It really gives a good description of the equipment that's in there, the testing that's required, and kind of a pretty good history. So I highly recommend it. It's a free document, and I really just recommend you checking it out. So now we're going to kind of go into how our rules are written and what we want to see as regulators, and hopefully what you're seeing your tester doing. So how our rules are written, this testing that we're talking about today is called the release detection operability testing. And that's the reference in case you ever want to look it up. And it's like I said, some people call this the tank gauge certification, but per the rules, this is what we call it. And in this testing, we're asking there's two components of this testing. We want the tank gauge to be tested, and we call out, you want to test the alarm, you want to verify the system configuration, and test the battery backup. So here's a Vita route at a facility. And a lot of questions come up is like, well, what alarm am I testing, right? Because there's a bunch of alarms on these facilities. People are familiar with the overfill alarm, but there's various others. And we're not asking for the overfill to be tested yearly. You can, but we're not asking to. We're not talking about that. In general, we want to make sure that this tank gauge, this specific Vita route as an example, there could be others, Incons, and there's a few others out there, but it goes into alarm. If there's ever an issue with your probe, this is a tank probe that goes into your tank, and there's a catastrophic release and all of a sudden you lose 10,000 gallons of fuel, as a bad example, we want to make sure that this Vita root goes into alarm. So that's what we want tested, is does this alarm? And then you want to verify the system configuration. I call it the in-tank setup report. I don't know the official name, but that is basically, how is this tank gauge programmed to communicate with this probe or sensor, something that you have out there. So as an example, let's say you have a facility with 3 underground storage tanks. Like, we want to see maybe 3 probes in those tanks, and we want those programmed correctly. We want to make sure that the diesel probe is programmed correctly, the unleaded probe is programmed correctly, and all the other parameters with that. So that's what we're looking for you to look at. And then if you have a battery backup, we would like that tested. Not all facilities have it. Sorry, not all tank gauges have it, but some do. And if you have any questions about how to test the battery backup, your manufacturer instructions will tell you how to do that. Veeder-Root and Incon, they both have great manuals. You can check that out. Along with the tank gauge, we also want the probes and sensors tested. And this is a tank probe. This goes into the tank. It goes into the fuel, right? And this is a float. And what we specify in the rules, we want to make sure the floats move freely. So that's this part right here. We want to make sure that moves up and down freely and that it's clean. And then we want you to test the alarm operability and communication with the controller. That's how we word it. But basically, we want to make sure that this probe is programmed to communicate with this tank gauge. There's a bunch of different parameters that needs to be included in there, but that's what in general what we want done. And this testing in our rules, we state, can be done in one of 3 ways. You can follow the manufacturer specifications. So Veeder-Root has their own document that demonstrates how to do all this testing. It's a great document. They have a lot of forms to use. I recommend it if you have one of those. If you don't have the manufacturer specifications, you could also use a code of practice. And the only code of practice we know about, and I'll talk about it in a minute, is from the Petroleum Equipment Institute. The document is called PEI RP 1200, and Kevin was actually on that committee to help put that together. But that's another code of practice you could use. It really spells out exactly what we want done. You test the alarm of the tank gauge and you test the probe. Or if you can't find either one of those, because there is a cost associated with this PEI document, we have finally come up with our own testing guidance. And I do want to state that these testing procedures are almost identical to the PEI document as well as the manufacturer's document. So we didn't come up with anything new. We just tried to summarize it into one document for you to look at in the field. So again, I just wanted to highlight a few of the documents we used when we generated this form. So this is that PEI document that I was mentioning about, and there's their website. This is a great document. It has overfill testing, spill bucket testing, containment sump testing, as well as this operability testing. This isn't an inexpensive document. I think it's a few $100s, and you can order it through them. That's one document you can use. These documents are free and they're actually on our website, but this is the Veeder-Root's operability testing. So let's say you have the Veeder-Root 350, feel free to use this for your testing. Or if you have a Franklin or an Incon or an EBO, that's all the same company now, you can use their manufacturer. But again, we also know there's different tank gauges out there. We know there's some Eco 1500s and Omnitex. I think we have an actual Red Jacket and Milton Freewater. And I saw an Autostick Junior in Hillsboro. They don't have testing manufacturers specifications, but they still operate. And at that point, you would use the PEI document or our testing form. So I just kind of want to highlight that we didn't just come out of nowhere when we created our form and our procedures. Right now, the testing form is actually live on our website. If you go to the publication side and our testing forms, you'll see it highlighted right here. Please download it, go start using it if you'd like. We also have some hopefully they're helpful documents to utilize this form. To me, it seems like a pretty simple, intuitive form, but just to clear up any confusion, we put some help documents out there for you to use, but it's live. Please feel free to use it. What else do we got? Oh, so this is the actual form. So it's a 2-page form, front and back, pretty simple. It's broken up into 3 parts. So I think it's simple. Hopefully it's simple. We have our testing of the tank gauge right here, this part of it. And then the second part is testing of the probes, which we pull out of the tank. And then the third part on the second page, back side of it, would be the testing of your sensors, right? Your interstitial sensors in the tank or on the tank top sumps. And then on the bottom of the second page, we have our procedures, which again are the same as basically PEI documents. So this is a 2-page form. Please use it if you feel free to use it. It's not a mandatory form. We don't have in our rules, you have to use this form, but we actually, as an inspector, we recommend it because what we're seeing out in the field is different forms out there. Some are better than others, and maybe not all the testing we want done is being captured. So if you as an operator want to suggest to your contractor to use this form, that'd be great, right? Because if you follow this form, the chances of you being liable for any deficiencies is reduced. If you're using some third-party form that maybe doesn't comply to our rules, there could be more problems later on. So again, form's live. Please use it or recommend it, or give us feedback. If you think there's problems with it, let us know. So on our website, I also have little instructions on how to fill out the form. I think it's straightforward, but just to make sure, these aren't instructions to do the testing, it's just to utilize this form. So as an example, the first line we put is like, enter your facility ID. And for some of you, you may not know your actual ID, your facility has a different thing, right? But on your operating certificate that we send out yearly, it's this number right here. That's your facility ID. And then your facility name, again, is on your operating certificate. So here would be TriMet Bus Garage. You may know your facility as something different just because maybe you changed the name internally, but on your operating certificate, this is how we know it. And so you would just kind of fill out the form going through that way. And one of the big things I want to highlight here on this form is it's for testers, if there's any out there, and for operators to inform your testers, it's going to be critical for you to understand what type of leak detection you're using at your facility. Each facility does it a little differently, but it's going to be important to know, as an example, if you're doing tank gauge monitoring, that could be, shorthands, you could be having an incon system and you're doing SCAL testing, or a beta root system and you're doing CSLD. That's your tank gauge monitoring. You're going to want to test your tank probe. Now, if you're doing SIR, statistical inventory reconciliation, you'll have to want to test those probes specifically for that. And if you're doing interstitial monitoring, you're going to want to test that sensor, not necessarily the probe. So there's a little variation, and it's going to be critical for you to understand that, to know what needs to be tested. And I'll get into that in a second in greater detail. We also put on the form, just like we filled out this form on site, pretty simple. We feel it's simple. It's not, this isn't a real facility. We went to DB Cooper spot. They had 3 tanks. We tested their probes. They also had 2 tank top sensors. We tested those just to make sure everything worked. We followed the PEI guidance document. And this is the form that I would present to the inspector if I own this facility. Now, the one I'm going to talk about next, which is probably going to cause a little grumbling from contractors, is going forward, we want to see, Oregon DEQ wants to see what I call in-tank setup reports. We'll explain that a little bit more, and alarm history reports attached to these testing documents. So you can print these out at the end of the testing and staple them to the form. You can print them out. You can put them in an envelope for later use, but it's going to be critical going forward that we have these, and I'll explain why in a minute. But again, this is what the form would look like. Photocopy them, take pictures, staple them in, but that's in general how we want this to kind of look. Again, you don't have to use this form. You can use a different form, but we are going to start requiring these tapes or some sort of verification that the testing is done. So again, it's just going to be critical to have these tank tapes. Like sometimes you show up to a facility and that's exactly what we see, which is kind of a hassle for us. But if these, after your testing, we want to see this stuff printed out and attached to the form. It's just going to be critical. And we're going to pause right after this slide for a quick second. But so again, I just want to highlight, it's critical for you as the operator and or tester to understand what's being done at your facility. So as an example, if you're doing what's called this 0.2 gallon per hour testing, that's your monthly tank leak detection, SCALD, CSLD, or static testing. You're going to want to test this probe right here. You're going to want to remove it and test it and do everything that needs to be done. Now, let's say you have a tank that was installed after March of 2008, or for various other reasons, you're doing interstitial monitoring. You're going to want to test this sensor right here. So what we see sometimes when we show up to this facility is a tank was installed, after March of 2008. They're doing interstitial monitoring for their monthly tank leak detection. However, their tester tested this probe. So that's great that this probe was tested and works and communicates with the tank gauge. We'd like to see that. However, the method of tank leak detection wasn't tested. And so then that causes a problem, and we communicate with you as like, oh, the appropriate sensor wasn't tested. And you're like, well, I hired my contractor. Like, we understand, but you need to test this sensor right here. So this is very complicated. I shouldn't say it's complicated. Each facility is different and unique, so it's going to be critical for you to understand it. And if you don't know what you're doing, please contact us, and we can help you troubleshoot it out in the field or remotely or something like that. So I know I've covered a lot in general, and I got a few more slides to go that goes into more detail. But I was going to ask Lauren if we have any hopefully simple questions that we could answer right now, or not. If not, that's great.
Yeah, so I don't see any questions in the Q&A currently. So just a reminder to folks, if you, as Mark goes along in the presentation and Kevin later, if you have questions, you can open the Q&A and type them in. If you don't have a question, but you see a question that you want to be answered live, you can also upvote that question, which is similar to the social media like, if y'all are familiar with social media. So please type in your questions. We'll be happy to answer them. And then also you can, when Mark is done, we'll do kind of more Q&A, and you can raise your hand to be unmuted and ask your question live as well. And in the meantime, I see that we are getting a couple questions, so I'll start with this one. Is there an age limit on USTs? Mark, do you want to go in on that?
Yeah, that's a tough question. It's not directly to this, but usually warranties, so your tank manufacturer like a Xerxes or a containment solution, they give a 30-year warranty. And so that's usually the life expectancy of a tank. We know there's tanks in there longer, but that's what it'll be warranted for.
Great. So the next question I see here, so the release detection operability test, is that a third party or the operator's test to do?
So either or, I view this could be maintenance of your facility. So there are a few operators that do this themselves. They're more confident doing it, and they believe they'll do it better than a contractor, and they will pull their probes. It's their equipment. So yes, if you feel you're confident in following any one of those forms and you can document your testing, absolutely.
And I would add to that just to say, as an inspector, most facilities that I go to elect to have a third-party contractor do that testing for them. But as Mark said, that's not required. Another question. I didn't see anything mentioned about electronic line testing, PLLD.
Right. So unfortunately, when I was putting this together, yes, that needs to be done yearly. For this presentation, we didn't talk about it because then you start branching off and you can get to really deep into minutia and questions. And I was just trying to focus on the tank gauge and the probes and sensors. That's the biggest problem we're seeing out there. But annual line and leak detection testing needs to be done, and that's a whole different parameter that Kevin can definitely talk for hours on. And he has. It's been great. So we simplified this presentation just to hopefully help. I don't know if it does.
And the last question I see in the Q&A right now is, can you go over the DEQ certification, ICC, et cetera, requirements for persons performing annual release detection operability testing?
So for this testing, which I'm about to explain, as long as you're not doing a line tightness testing or leak detector testing, there's actually no ICC certification that I know of. Our rules are a little unclear on that. There are one at UC, so I forget the acronym now, but there is a test. We can answer that later. We'll put that in a little summation, but there is a test you could take for line testing. I forget exactly. It's UC1, and I forget what UC stands for, so I apologize. But for this testing, this is your equipment. So as long as you feel okay. I do know Veeder-Root as an example. I think they state you need to be Veeder-Root certified. Now, what does that mean? I'm not exactly sure. Like, you're paying for the equipment, so I don't know. So hopefully we'll answer that later. So in summation.
And we have a couple more questions, Mark, but do you want to go ahead with the presentation and we'll get back to these when you're done?
Yeah, let's kind of go through and hopefully we can get Kevin up here, get to the main act.
All right.
All right. Thanks, Lauren. Okay. So again, it's going to be critical to understand if you're testing your probe and a sensor. So the next couple of slides are going to be talking about testing a probe and a sump sensor. Again, every probe, not every, but probes and sensors can be different. I was just out with an operator who was willing to help us with the form, and this is what we did. So as an example, for this Veeder-Root system here, if you follow the PEI method, our method, and Veeder-Root method, this is a very quick summary. This isn't every step of the way. Please reference those manuals, but as you as an operator, if you're watching your tester, this is kind of in general what you're going to want to see for their probes. So the idea is you disconnect the probe, and at this point, your tank gauge will go into an alarm. So in this case, it was the Veeder-Root, it went into alarm, right? So we saw that you disconnect it, like, oh, alarm, we know it's working properly. And then the next thing you want to do is you want to clean off these floats, and you want to move these floats up and down. So this is what's in your tank, with the product. I think this one, Kevin probably can answer better. I think this is your fuel probe. So as you're getting a delivery, you start off at 2,000 gallons and then you go up to 7,000 gallons. This float is what's moving up and communicating with your tank gauge. And then this float right here is your water float. So you have the gas unleaded tank with ethanol, and it starts to phase separate, and you start getting water in there. This float will start to rise up, and it'll tell you have water in that sensor. So you want to clean these floats, you want to move them up and down, you set a little tank tape down there. And then if you look at the PEI document, basically you want to take a measurement of the fuel and the water. I'm not going to go into great detail on that. Your tester should know that. These documents explain it. Please reference the Veeder-Root and the PEI document, but it's a bare minimum. You want to take one of those measurements. And here, when we were in the field, we tested this water float. So what we did is we raised up this float until it triggered an alarm at the tank gauge. We printed out what it was supposed to be at. I forget, it was like a few hundred gallons of water. We verified that with the tank chart, and we were good to go. So again, this is just a quick summation of how to do this, what we did out in the field. And so when you're done your testing and you're satisfied with it, you just want to put the probe back in place, and then you want to print off your alarm history report. So, this isn't the whole procedure. Again, I'm just trying to summation of quickly what you may see out in the field. Now, these alarm history reports, for this specific Veeder-Root, for the specific system, one of the things we're going to look at when we see these, are we going to want to make sure this testing was done per one of the methods, and every method calls this out. So in that previous example, you saw as we disconnected that probe, it went into alarm. So that tells us that that day, at least that probe is disconnected. And then also we saw that they raised the float, and then the high water alarm went in. So at a minimum, we know those two things were done. Those are two things that are specified in our documentation and the PEI and the Veeder-Root document. So we're confident this was done correctly. So that's one method, that's to test a probe. Here in the same facility, we tested a sump sensor. It's not the best picture, I apologize, but here's what we call the Veeder-Root 208 sensor. We see it in tank top sumps or dispenser sumps. And that testing procedure is pretty simple. You would place this sensor in testing fluid, they call it. We used water because this is a non-discriminating sensor. Keep in mind, if you have what's called a discriminating sensor, you want to test it per that fluid. So if this is a unleaded tank with regular fuel and it's a discriminating sensor, that has to be fuel basically for the testing. So you place the sensor in there. It should go into alarm. You want to double check everything, make sure that this is the right sensor. This is the unleaded sump sensor, and it went into alarm. So your sensor was tested. You clean off your sensor, you place it back into the position it needs to be, and then you print off your alarm history report. So that's just the tank top sensor. I don't have an tank interstitial sensor, but again, you would have to pull that sensor and test it out. Kevin can talk a little bit about that. Now, this is maybe an ideal situation, right? It's a Veeder-Root with a printer and the tank gauge is right there, but that's not every situation, and we understand that. So there's always going to be these what ifs. What if I don't have that, right? Here's a tank gauge that it does spit out paper, but the printer doesn't work. So we don't know. You disconnect the probes, it tells you that it went into alarm here, but we don't have that printout. And then we have some of these simpler tank gauges where there actually is no printer. It just goes into alarm. And then here, as we were at a facility, and then this tank probe is actually hardwired to the tank gauge, so you're not going to disconnect that, so it'll never go into probe out. And so the question is, well, what do I do on these situations? And that's going to be very unique, and we understand that, but we're going to ask to put notes. It doesn't have to be these great detailed documentation, but you just explain site conditions, right? Showed up to site, this probe cannot be disconnected. So as regulators, if we see some notes, then we have a better idea of what's being done. If you don't want to include tapes as an example, you can include pictures. You just want to show evidence that this was done correctly. And lastly, video is also helpful. I did an inspection a few years ago where the operator wasn't comfortable sounding the overfill alarm, but the contractor was there. So the operator filmed the contractor hitting the Vita root buttons to sound the alarm. The alarm went off. I could hear it, and they turned it off. So it was just evidence that the alarm worked the proper way that day. So again, it's going to be up to you to determine, to communicate with us the best way to get this information out there. And I'm going to give you this next slide is kind of silly, but it's an example of another way to look at it, right? So for this facility, we're going to assume that the testing was done correctly. That's not the concern, that the testing is done, but you're given one of these two documents. You're either given this document, which kind of explains in greater detail what was done. There were some issues, maybe there weren't issues, and how you discovered them and how you took care of them, the method you tested. Or you're given this document, and sometimes we see stuff similar to this. It's like, yep, showed up, done the testing. And the question to you as an operator, you're paying for the service, is which one of these forms is worth $1,000? That's another way to look at it. Like, you just want to have enough evidence to give to us to say, yep, see, my contractor did this testing the correct way. Just a different way to look at it. Another question that comes up a lot during inspections is, how long do I keep these records? So this varies, our rules, a couple different parts talk about different things. For this operability testing, we say, well, as long as that probe is in use, you got to keep that testing record. So let's say this probe has been used for 20 years and you've been testing it for 20 years, you should be keeping 20 years of records. When we show up to do our regular inspections, we're just going to want to see the past 3 years of testing typically, right? And that helps us verify that the testing was done correctly. It's being done on an annual basis. Make sure there's not any issues. So again, just want to keep 3 years. You're supposed to keep them longer, but we're going to want to see 3 years. So I'm coming up to the end, and then we're going to get Kevin. And I know I've thrown a lot out at you, and you may feel like, oh, I don't know what's going on. Like, you're operators, you're busy, completely understand. You got personnel, you got to pump fuel, you got a whole bunch of other inspectors, and then we're coming at you like, you have to know what's going on, right? So, but I don't want you to feel you're alone. So if you're out there anywhere in the state and you have a tester and you feel like you're not getting the service that they're providing, please contact us. We can communicate with your tester with your permission. And also, we can be on site from time to time. We can't be everywhere. Like I said earlier, we have 1,700 facilities with 5 of us, but if we have enough warning, we may be able to go to the site and talk with the tester and speak with you. This wouldn't be a regular inspection, but it's an opportunity to utilize us. We can help you gather paperwork and stuff like that. So please feel free to communicate with us. Some of the rural areas out in Eastern Oregon and Western Western Oregon, you may feel isolated. That's not the case. We're across the state. We're sometimes in those areas anyway. As an example, we have somebody's installing a gas station in Redmond, and there's another one going on in Umatilla that I've been checking out. So if you're in Pendleton and your tester, you don't feel like they're doing a good job, let's say in the next few weeks, I may be out there anyway. So please contact us and we'll go out there and kind of, communicate with you and hopefully help out the situation. Like I said, we didn't just generate this form out of the ether. We actually met with a few people. We met with Ron's Oil in Newport. He explained how he does his testing, very helpful. Same thing with Leathers Fuel. We met with them in Prineville. They pulled their probes for us. That was great. Portland Community College, along with their tester Mascot, again, they did their testing with us. So that was very helpful. I'm hoping to do these again in the future, and we want to get out to the outlying areas of like Pendleton, Baker City, and Ontario, and Brookings, to generate these forms. We want you involved. This is to hopefully help you as a regulated person. And finish up. Lastly, we're at the very end of this whole 2-hour webinar. We're going to just drop this survey in here. It's a 5-question survey. Please feel free to ignore it or answer it. I'm surveyed out too, but I'm hoping if we do these in the future, they're just helpful to you and you can get something out of it. And like I said, this presentation will be online with my contact information. If you have a question for me, please send it to me. Or if you have a question for someone else in the program, I can probably send it out that way. And that's quickly what we had to say. I'm hoping that made sense. I understand I'm in the middle of it and you guys are fighting. So just want to make sure that's fine. So we're going to take a few seconds to answer a couple more questions, get Kevin set up, and then he'll talk about it more of on a national presence. So do we have any other questions, Lauren?
We do. All right. So first question, do the sites with piping upgrades after 2008 still have to do daily sensor monitoring with monthly walkthrough inspection?
Not daily. That was changed in 2018. So you can go to monthly. Hopefully that helps.
Yes, and if folks want to ask a question live, feel free to hit the raise hand button and I can go back and forth between live questions and questions that have been typed in. So if you want to do that, go ahead and raise your hand. The next question that we have here, numerator is tank gauges and monitors still being used, and does everything mention? So I'm not sure I fully understand this question. So does somebody want to kind of expand on this question a little bit more on what they're asking? If you do, hit the raise hand button and we can unmute you to talk through your question. All right, not seeing anybody, so I'll move on to the next question. If you were slow to hit the raise hand button, please hit it and we will circle back because we want to try to answer folks' questions as best we can. So the next one here, I upgraded in the spring of 2020 by using Tank Tech, who goes in and basically rebuilds a new tank inside your existing tank. Interstitial monitoring is installed. Does the Veeder-Root monitor both working of the probe and the interstitial, or will it only monitor one of these?
So hopefully your contractor, so most likely on that situation, right, Tank Tech did the build, and then there was a third party, another contractor, let's say a Mascot or SME or maybe even Central Services, and they put in the probes and the sensors, and they should have programmed that to the tank gauge. And if they haven't, we can definitely help you with that. We've seen that a few times on the different places. Maybe the probe was installed and not the sensors, but your testing contractor most likely installed that. But again, please contact me after and we'll go through your system and see if everything is programmed correctly.
Great. Next question. Veeder-Root certified typically deals with warranty and help desk support. Veeder-Root will not support non-certified individuals. So I think that's just a statement here.
Right.
Yeah. Do you want to add anything to that?
No, that's a good point, and we don't have the resources to really, track that down. That is something to consider if you're hiring a third-party contractor to do this testing and they're not Veeder-Root certified, and then there's a problem with the equipment that will be a concern. That could be a concern for you. So it is, as an operator, it's very critical for you to understand if these people have the right certifications. It's a little tough to figure out, but that's a great point. I think Incon might be the similar. I'm pretty sure all manufacturers are the similar. Like they want to make sure you understand how to work on the equipment. Kevin can probably talk a little bit more on that in his presentation. So any other questions, or should we?
We do have a couple more
Okay.
here. So yeah, just let me know, Mark, when you want to switch over to getting Kevin set up to present.
Yeah, a couple more minutes. I think we got some more time.
All right. Next one here. I am interested in hearing more about how to make sure the floats are set to measure the fuel and water. I saw a tape measure next to the floats and they were about 7 inches apart. How does this part of testing work in more description?
Yeah, I'm hoping Kevin will be able to expand on that a little bit. Kevin is a tester, so he does this testing. So I'm hoping he's picking up on that question and he'll answer it more. And if not, at the end, if you don't feel like you've gotten the answer, please let me know and I will reach out to who we got to reach out to and we will definitely get your answer. So sorry, we tried to bring in Kevin because he is more of a technical expert on this as opposed to us. So I'm hoping he explains it better.
Great. More on that one later then. We got kind of another statement here. National Work Group leak detection applies.
Yep. Yeah, and just so, and that's a great comment, and I can expand on that later. But all your equipment must be what's called third-party certified. So as an example, your Veeder-Roots or your Incons or their sensors or even tanks, they had to be tested to ensure that they work with the fuel and the different testing method. It's a very involved process to do that testing, but yeah, every leak detector out there has got to be third-party certified, and so that's a great point.
All right. Next question here. How do we learn how to check an interstitial? I think this is what we're going for. Interstitial system annually. We are used to an inspector checking it every 3 years. This is for a tank for an emergency generator.
What was that question again? You broke up for a second.
How do we learn how to check an interstitial system annually? We are used to an inspector checking it every 3 years. This is for a tank for an emergency generator.
Sure. Yeah, that's a great question. So this testing should be done yearly. You could do it if you feel comfortable, but like they said, if you got to be careful, make sure you meet the manufacturer specification. But third-party contractors, we have a list of them we can send to you. Technology, SME, Mascot. There's others, petroleum compliance services. There's others that can help you with that, and they can show you how to do it too. So, or your manufacturer specification. As an example, if you have a Vita root system, you can download the documentation and they'll explain exactly how to do it. But so those third parties can help you with that too.
All right, last question in the Q&A for the moment. How long does a liquid sensor have to be an alarm to be considered a suspect release?
Yeah.
Example. So the example here, groundwater is persistent on site. It cannot be controlled. So the liquid sensor is in constant alarm.
Yes. So we don't have anything specifically written in the rules saying, 30 seconds, it's an alarm. So the idea is every time it goes into alarm, that's, is it a suspected release? Yes. But it could be remedied right away also, right? Like you open up the sump, you see it's full of water, you're like, oh, it's water, you pump out the water, you reset the alarm and you're good. So just because that terminology suspected release, that doesn't mean there's actually fuel going into the environment. It's just like, oh, your alarms and sensor indicate there may be a potential release. We do see maybe on the coast and a few other facilities, they are seeing penetration into sumps. That's a difficult answer. We don't have an answer to that now. Ultimately those sumps need to be tight to stop the liquid going in. But as long as you're on, the best way I can explain is if you're getting alarms frequently, as long as you're documenting it, saying, yep, just water pumped it out, you're covered, right? What we don't want to see is we show up to an inspection and you're like, yeah, this has been an alarm for 60 days. That's a problem, So we can get into that in a greater detail later. And I think that's going to be a topic of a future webinar, maybe, I'm hoping. So, all right, well, hopefully we've got more questions, but I want to give Kevin a chance. So I'm going to stop sharing my screen if I can figure out how. And I don't know if I can. Maybe Kevin can just take over. And then I want to introduce Kevin. Let's take a look. I can't turn it off.
It might be near the top of your screen.
We'll share on. You are sharing. Stop share. All right. Hopefully Kevin can load up. Let me introduce Kevin. I got a little write-up for him. Kevin is great. We've listened to him. So Kevin's going to talk a little bit. And Kevin Henderson, he is actually a consulting storage tank professional, providing a broad range of training and compliance-related services with specializing cathodic protection. So Kevin's career spans over 30 years, including extensive regulatory and private sector experience, allowing for unique perspective of the many challenges faces regulation operators, maintenance of UST systems. We asked Kevin actually to participate because he actually has done similar presentations for us. For the EPA, we've sat in on those inspections. I've been to a couple of his cathodic training. Well, one of his cathodic trainings really great. And he actually did a similar presentation in the National Tanks Conference in 2022 in Pittsburgh. So he has pretty extensive knowledge of this material, and we just wanted to bring in somebody that, not from the area, that's actually out there testing, that can demonstrate more of what's being done and observations. And Kevin mostly spends his time in the Southwest out of Mississippi, so hopefully Kevin is ready to go.
I think I'm ready, Mark. Thank you very much.
All right.
PowerPoint is up.
Give it a second.
Can you see my PowerPoint presentation? Okay, cool. Thanks, Mark. Well, again, really good general overview, introduction of what's going on with testing of these systems today. Again, I do appreciate your effort to help people understand this, because it can be very confusing. And one of the things that I've always tried to do when I do training is bring things down to the very simplest terms possible. You've got to keep it simple. So I'm going to try to do that today. You may hear me repeat some of the things that Mark has already said, and there's nothing wrong with that because repetition is always good. When you get old like I am, you have to hear things several times before you can retain them anyway. So hopefully it won't be too boring to you. I'll repeat some of what Mark said. I'm going to try to help you understand and answer a couple of the questions that were asked earlier. And again, the intent of this, of course, is not to be the definitive reference that everybody's going to look at. Yeah, this is the way it has to be done or should be done. This is my perspective. Also taking into account that I have been involved with PEI RP 1200, which is the document that was created to describe how to do this testing. That committee met several times. This document took a lot of work to get put together. It was a very good beginning. The document still needs work, of course, just like everything else. So again, I'm going to try to convey to you today in practical terms how this testing is done, how it should be done, and point out some things that you may not have thought about before that are important from a documentation standpoint. So we're just going to jump right into it without any going any further and just say, well, the EPA put out a guidance document that describes how you do this testing. I think I may have lost my presentation. There it is. They put out a guidance document that describes the 5 things that have to be done relative to leak detection equipment testing. And so you can see them listed there, of course. Tank gauges and the controllers, which we'll focus on today, and probes and sensors. That's really what we're talking about today. We're going to, in passing, talk a little bit about vacuum pumps and pressure gauges, and just a little bit about leak detectors. We had a question about PLLVs earlier. I'll try to address that. And then finally, this almost insignificant thing called handheld leak detection equipment. So again, most of today is going to be about tank gauges, probes, and sensors. And I'm not sure why my computer is locking up on me. Well, of course, when it comes time for the show, it doesn't want to cooperate. But how is the testing done? So Mark has already told you this. There's 2 basic documents that we go by. PEI RP 1200 is, of course, the reference that applies nationally. Every manufacturer, just about every manufacturer, has their own documents on how to test their equipment. And again, all these are all public documents, which Mark has mentioned. Well, but relative to tank gauges, lots of tank gauges out there, many different kinds. The EPA says we need to do 3 things: test the alarm, verify the configuration, and test this battery backup. So clearly, I'm not going to be able to talk about the 45 different kinds of tank gauges that are out there today. Most of what we're going to talk about is relative to the good old Veeder-Root TLS 350, which is, of course, is by far the most common one. And it's the one that most everybody is familiar with. Omtech, see these generators quite a bit. The EVOs have been catching on. The 450s are around at the newer stores, of course, but most everything is still TLS 350s. That's pretty much what we're going to talk about. The first thing that EPA says you have to do, of course, is test the alarm. And yes, there are many different alarms on a tank gauge. But if you just look at this, the very basic understanding of what it means to test the alarm, you can simply walk up to like a TLS 350 console, find that red button, and if you just press that red button, what it will do is you'll hear the beeper sound, the little horn will go off, and you'll see the three indicator lights will flash. That is your indication that yes, the little beeper is functioning and all 3 of the lights are working. It can actually be just as simple as that. Verifying the alarm works is nothing more than hitting that red button, verifying that you hear that horn and all 3 lights are actually working. Verifying the system configuration. So that's a very broad question. You know, with the tank gauge, there are many different things that could be connected to the tank gauge. All kinds of different modules you can plug in, depending on what kind of equipment you've got. But basically what this is trying to get at, I think, is do you have the right size tank in there? Is it the right type of tank? Have you got the right thermal coefficient programmed into for the fuel that you have in the tank? And again, depending on what your method of leak detection is, you could have sensors connected to that tank gauge. You obviously need to make sure that the sensors are labeled correctly in the tank gauging system. You might be required to have STP shutdown if the sensor goes to alarm. You could have a PLD that's required to be programmed to shut down STP. So it just depends on what your leak detection method is as to what parameters you need to verify are actually in the system correctly. And so typically what you think about when you're verifying the system configuration is you're looking at the setup report. This is what VDROOT calls it, the setup report. And so if you just walk to the VDROOT, hit the function key one time and go to the next mode, the setup mode, and hit print, then you'll get this very long report. And it can be really, really long depending on what modules are plugged into the system, of course. There's only certain parts of it that you need to archive, if you will, and make part of the annual operability test report. Generally speaking, you're always going to see the in-tank setup portion of that setup report. You have sensors connected to the tank gauge, and obviously you want to have the liquid sensor setup portion of the report connected. If you have PLLDs, there's a little section of the setup report that deals with PLLDs. And if you're doing STP shutdown, there is another part of the report that has the output relay setup. So again, it just depends on what you have as to what parts of that report you need to make part of your annual operability testing report. Part of the thing that the EPA also says you have to do, and I believe Oregon does also, is you need to test the battery backup. You know, what the idea here is the console has a battery in it that will back up the programming so that if the AC power is interrupted at the store, the tank gauge does not lose the programming. So that's the purpose of the battery, of course. So the EPA wants to make sure that battery is actually working correctly so that power outages happen all the time. The way that traditionally has been done is a little bit problematic because, again, with the VDROOT 350, which is by far the most common one, the way that people typically would do that would be to simply go up and either throw the breaker for the power on that console or just pull the power wire out of the console itself and then plug it back in and see if the programming comes back up. So if the battery is working correctly, the programming will come back up. And if for some reason the battery is not working, then you just lost all the programming in the system. So it can be dangerous, it can be risky to test a battery that way. If it's not working, then yes, you will lose all the programming. The way that we typically handle that in the past is, well, the first thing you do before you do anything else, of course, is print the setup report, the full setup report. So that if the battery is dead, when you bring the power back up to the console, you can sit there and reprogram everything based on the setup report, which I've had to do that a few times in my testing career. It's not a lot of fun. So VDROOT came up with a better way to do that. But they have a procedure that essentially you're able to take a multimeter and measure the resistance across the voltage across some resistors that are in the PCM board, in the console itself. So all you do is really just measure some voltages across a couple of resistors. And if the voltage is measured correctly, then you can be satisfied that the battery is working correctly. You do not have to interrupt the power to do that. The procedure is a little weird. You have to get the manual out to understand exactly how to do it. And yes, it does depend on what kind of board you have in the system, but it's not that hard to figure out. You can test the battery without having to kill the power. So the second thing that the EPA says we need to do is test the probes and the sensors. I want to be sure before we start talking about this, because this can be confusing, that we understand what exactly it is we're talking about. And again, this basically comes from the V to root terminology, the vernacular that they use. It's what everybody knows, and it's what we all use in the industry. When you say something is a probe, what that means is that is the actual the in-tank probe, the probe that is inside the tank that measures the fuel level and the water level inside the tank. That is a probe. But when you say sensor, that is typically thought of as something that's in the interstice of a double-walled system. It can be an interstitial sensor in a double-walled tank. It can be a simple 208 V-root sensor that you see the picture of here. That's just their model numbers, 208. That's what everybody calls them. Very, very common. It's just sitting in a piping containment sump doing interstitial monitoring. So anything that is a sensor, the way that we test that and the way we look at that is different than if it is a probe. So just try to get in the habit, and it took me a while to do this myself, of calling things correctly. The probe is in the tank, the sensor is an interstitial sensor. And so we'll talk a little bit about the probe first, of course. Pulling the probe itself is not difficult, but it also can be risky. And I'll tell you what I mean by that in a minute. It is risky to pull a probe out of the tank. We don't like to do that unless we have to. When do we have to do this? When does the probe have to be pulled out of the tank? The only time it has to be pulled out of the tank for the operability testing thing is when you are doing 0.2 monthly leak testing, or you're using that probe as inventory for doing SIR. So if you're doing something else to meet the leak detection requirements, maybe you're doing interstitial monitoring on everything, there is no reason to pull the tank gauging probe. But if you do 0.2 monthly testing or SIR, then yes, you need to pull the probe and verify that it is actually functioning correctly. So the way that we do that is really pretty simple again, but you do understand that pulling that probe is dangerous. Why? I mention that because any probe that has been inside a tank for a period of time, when you pull that probe out, the only way to get the probe out of the tank typically is to disconnect the wiring. The photo on the far right is a little pigtail that V-root has to connect the probe to the wire that goes back to the console. And the picture in the center, of course, is the probe itself. And you see the two little pins in the middle there. That's just a plastic housing in there. And those two little pins are in that plastic. Sometimes when you disconnect this little pigtail and you pull it out of the probe socket there, that little plastic will just crumble in your hands. And that's a very bad thing to happen, obviously. When that little plastic crumbles in the probe, there is no way to fix that other than buying a new probe. So that is the main reason we do not like to pull the probe unless we absolutely have to. The pigtail will also come apart on you sometimes, but that's relatively cheap. That's about $150, or it used to be. I'm not sure what they would cost today with inflation the way it is, but it used to be about $150 to get you a new pigtail. But the probe itself can be quite expensive, so we just don't like to do that unless we have to. You also have to be careful when you pull the probe out of the tank of knocking the floats off the shaft. If you have 4-inch floats on your probe, and most of them do, and you're trying to pull it up through a 4-inch riser pipe that's corroded up, which most of them are these days, it can be a little tricky trying to get those floats up through that 4-inch riser pipe without knocking them off the shaft itself. There's the third picture. On the one this animation is on here, it shouldn't be. Anyway. So the thing about probes is, again, in the EPA, this is their guidance document again, it's ABCDE. ensure the floats move freely. Well, I mean, that's pretty obvious. Ensure the shaft is not damaged, obvious. Cables free of kinks and breaks, obvious. And inspect it for residual buildup. We're talking about the floats themselves will get residue built up on them. Test the alarm, operability, and communication with controller. And again, that's debatable what that really means. If you're doing point 2 testing, the alarm that you're talking about is a failed point 2 test. Well, how do you simulate that? You start pulling the probe. Well, you can. So I don't really know what they're getting at there relative to doing point 2 testing, but we can argue about it, we can talk about it, but the main thing is that we're trying to do is verify that the floats are actually measuring the fluid levels in the tank correctly. And so the way that you do that, we had a question about that again, is once you pull the probe out of the tank, you'll get the probe out alarm to lay the probe down on the ground, connect the wire back up, get it connected again, and what we'll do then is manually move these floats up the shaft, the fuel float up the shaft a certain distance, and take a gauging stick or a tape measure, lay it down beside the probe, the ATG probe, and we will literally measure how many inches that float is up the shaft. And then we'll go back in and look at the console and verify that the console says, yeah, I've got very close to the same inch reading on my console as what I'm measuring out on the concrete pad with my stick or my tape measure. That's really the main thing we're trying to do there. Verifying the float, the water float is accurate, is also part of the deal. And it's not just the fuel float. So you look at your setup report and you see what, okay, the high water warning and the high water limit are set at a certain inch level. Typically what you'll see is the high water alarm is set at 3 inches. That's very typical. I don't know why, but it just is. People will set it at 3 inches. So what you do, of course, is move the float to the 3-inch mark on the shaft and then verify that it does go into a high water alarm. And again, the whole idea is, are the floats measuring correctly? The other thing we also always do is we will manually gauge the tank for water. And of course, just water finding paste. And with ethanol fuel, this can be tricky, of course, we all know that. But we do want to make the effort to manually gauge the tank for water. So if you look at the inventory report for Veeder, it will always tell you the water level in the tank. And you see this one, an example is say 0.00 inches, and that's fairly typical. And so when you stick the tank, you want to make sure that there is no water in the tank visible on the gauging stick, but also you have to put a little caveat on that. This is something that not everybody realizes about tank gauges. And it's not just limited to Veeder. You need to look at your specifications, of course, on your probe to see what is the minimum level of water that probe is capable of detecting. And with a typical Veeder probe, it's like 0.9 inches. So we just say 1 inch. You have to have 1 inch of water in the tank before that probe will even register any water in the tank. So that's why a lot of times you'll see 0.00 inches on the Veeder report. But if you went out and did a manual sticking of the tank, you might see, well, it's got a ½ inch in it or whatever. So the tank gauge just can't see anything that small, that little. So you just need to be aware of that. I personally do not like relying on the tank gauge to tell me if there's water in the tank or not. I still want to periodically manually stick that tank. And of course, this is one of the other issues that you want to be sure you look at, the residual buildup on the floats. You know, these floats stay in these tanks for a long time. And these days, with all the biofuels that we have and ethanol fuels, and things happen inside tanks that are just really weird sometimes. You know, getting this kind of crud on your floats is never good. It's not a good thing, of course. So part of the annual ATG probe pulling operability test is cleaning these floats up, cleaning everything up, making sure it's all the way it should be. Okay, and so I guess the heart of the matter relative to testing the tank gauge and probe is you need to be able to document that yes, you in fact did pull the probe from the tank. You did in fact verify that the floats were reading correctly. And the way that you can do that is kind of limited, but we do the best that we can. And so one of the things we're going to do is include these reports from the Veeder-Root itself. We're going to print these reports if possible. And we're going to include these, make these part of the report. Mark has mentioned this already, of course. The one thing I would mention about including these Veeder-Root reports is that you do not want to rely on the little tape itself to be a permanent record. These are thermal printers on these tank gauges. Of course, that's thermal paper, so you know what that means. That if that paper little printout lays out in the light or the sunlight in particular, it will very quickly fade away. They're not, UV light will quickly destroy these reports. Within a matter of weeks, they'll be gone. You'll be looking at a blank piece of paper. So even if you put them in a file folder, it's still possible for them to fade away over time. And so anytime I do this, I will scan these reports and make that scanned copy or a photocopy part of my report. I never rely on the thermal paper itself. And so you see the intake setup obviously should be part of that, what you're looking at. The alarm history report is an important part of this. And so this happens to be the in-tank alarm report because, again, we're looking at the probe itself. So if you know that Veeder-Root, you know that there are several different alarm history reports. This one actually happens to be the in-tank alarm, which will give us the record of the high water alarm and the probe out alarm that we're looking for to show that, yes, we did pull the probe out. Yes, we did verify that the floats are reading correctly, or at least appear to be. And of course, I always like to do this because if I'm pulling the tank gauge and probe, typically it's because someone is doing 0.2 testing, whether that's static or CSLD, or maybe it's an in-con scald. I am just going to print the last pass 0.2 test in that system. I'm also going to make that part of the report because clearly the reason that we're pulling the probe is because they are doing 0.2 testing. You want to make sure that it is in fact doing 0.2 testing. So the easiest way for me to do that is to just simply print the last passing or last test result for 0.2. This is an example of what very commonly is seen. The top part of this is an excerpt of some tester's form he has. And you'll see they got this correct. This section must be completed if in-tank gauging equipment is used to perform leak detection monitoring, meaning they're doing 0.2 testing. And then if you look at the other highlighted question there, the fourth one down, was accuracy of system water level reading tested? And he indicated yes. He checked the little box yes. It's easy to just check boxes on a form. We always want to back that up if we can. And so the way we do that, of course, is print the alarm history report to show that, yes, the water alarm did go off on the same date that I did the testing. In this example, it was March 8, 2021. So if you look at the two Veeder-Root reports that go along with this annual testing report, you see the in-tank setup. Okay, that's great. But then you see the alarm history report for the in-tank alarm, and you do not see any high water alarm or warning for March the 8th, 2021. The last one I talked over a year ago, in April of 2020, near a year ago. So even though this guy was there on March 8th and said he tested the water floats, he did not show me that. He didn't document that. It looks like he just checked the box. Okay, so that's enough about the tank gauging probe. We'll shift gears a little bit and talk about sensors. There are lots of different kinds of sensors out there, of course, many, many different sensors. The vast majority, I would say probably 90% of everyone that I ever see, at least in the South, are these, quote, Veeder-Root 208 sensors. All they are is a little float switch. They do not discriminate. All they can do is tell you there's liquid in the sump or in the tank. Interstitial, they're just float switches. That's all they are. We do have some hydrostatic monitors. Of course, that's the top right picture. Don't see any standalone sensors. That's the bottom picture. The middle right picture, that's a tank interstitial sensor. And boy, that one is trouble. That's a lot of fun to deal with there. But almost all of them are just non-discriminating float type sensors. So the test procedure is really, really simple on a float type switch. The idea is, again, it used to be in the old days where we just go out and pick the sensor up, turn it upside down, causing the float to move up and make sure that it triggered the alarm. And of course, there are people who will still do that, but that is not in accordance with the testing requirements for PE RP 1200 or any manufacturer. Any manufacturer's procedure and RP 1200 would tell you that you have to submerge the sensor in a test fluid. Typically, that's just water because they're non-discriminating sensors. It's just water. And so you take the sensor out of the sump or out of the tank interstitial, place it in the test fluid, and verify that it does go into alarm. But that really is all there is to it. I mean, that's it. An optical sensor, we do have some of these around. You'll see these typically like an Omtech system uses a lot of optical sensors as an example. Optical sensors, again, you submerge it in a test fluid, but you just need to be aware that it has to be in a dark environment. So just putting it in clear water in a bucket out in the sunshine, you are not going to get an alarm on an optical sensor. It has to be covered up with a towel over it or have a very dark test fluid. Something it's got to be dark for an optical sensor to work. And with a discriminating sensor, I really do not like to deal with these. I've only got one place that has these, and they're just kind of a pain in the butt, honestly. But what you would do is, of course, immerse it in water, hit the alarm, then you have to immerse it in fuel, whatever fuel is in the tank, and verify that it will go into alarm with that. So the typical Veeder-Root sensor, again, this is where this comes from, in a gasoline environment, it can take it up to 20 minutes to go into alarm. And if it's diesel fuel, it can take up to 1 hour for it to go into alarm. So it's not a lot of fun testing those, but you do what you got to do, of course, and then it takes 1 to 3 hours for those discriminating sensors to recover. They got to dry out completely before they'll go out of alarm. I'm happy we don't see many of those around. The thing I wanted to mention about the middle far right picture, that's on a tank interstitial sensor, and this is for a fiberglass tank. If you're unlucky enough to have a double-walled fiberglass tank and you're doing interstitial monitoring on that double-walled fiberglass tank, then you know that pulling that sensor out of that interstitial of that tank and getting it back in can be real trouble. That is by far the biggest issue we have with doing sensor testing are these double-walled fiberglass tanks. I can't tell you how many times the little pull string has broken. The sensor is hung up somewhere within the rib of that tank. You cannot get it out. And if you do get it out, you completely tear it up. And getting it back in can be even more fun. We have spent hours with fish tapes trying to get sensors back in to double-walled fiberglass tanks. Anybody who's dealt with this knows exactly what I'm talking about. But again, it's a necessary thing. And the reason I'm bringing this up, and you'll see in the second why, that people really do not like to have to pull the interstitial sensor on these fiberglass tanks for this reason. And so you might see them try a little trick, if you will, that they think they can get away with without having to pull the sensor. And I'll explain what I mean by that in just a second. But relative to reports that are needed to document you actually did the sensor testing, this is pretty simple. Again, this is the Veeder 350 setup. What you need to be able to show is the liquid sensor setup. So this is just a simple report you can get from the setup report itself. It's just a part of it. And what it does is it describes every sensor that's in the system. It tells you where it is at. It should be labeled correctly. And it tells you what type of sensor it is. So you need to verify that it's labeled correctly and that it is the right type of sensor. The second part of that, of course, is the liquid status, which everyone knows how to get that report who does interstitial monitoring. The regulators always want to see this. The liquid status is made part of the annual operability testing report. And what the idea here is, the way I like to do this, you notice that Veeder will date and time stamp these reports. And you see that this one says April 8, 2022, 1:25 p.m. You want to make sure that that is the last thing you print before you leave the site, right? You want that time to show that all sensors are normal after you have completed all the testing. That's just to protect someone as a service provider or a tester, that when I left that site, every sensor was in a normal condition. And I can show you that by the timestamp on it. I left at 1:30. Here I am right before I left, 1:25. Everything is back to normal. And then the sensor alarm history report, of course, obviously is where you document that you actually did cause those sensors to go into alarm. If you know how Veeder works, you know that the alarm history reports will only capture the last 3 alarms of each type. So you see the L1, regular unleaded sump. That's the STP sump. There's the July 27, 2021, 1:55 timestamp. That date better match the date that you were there doing the annual operability test. And of course, if they have alarms after you leave, then that will go away. But you have that part of the permanent record of your test. You printed that history report when you were there before you left, and it became a part of your test report. That's how you prove that you actually made it go into alarm. And so some places, again, we mentioned are required to do STP shutdown. And what you typically think about this is there are certain places who have chosen to do what is called low-level sump integrity testing. Beyond the scope of our discussion today, of course, but low-level sump testing is something that the federal EPA has allowed and most every state recognizes as an acceptable alternative to the 3-year containment sump integrity testing requirement. So those are what they call this low-level testing. And basically what that means is you only have to test the bottom few inches of the sump as long as you have sensors in that sump that will cause the STP to shut down if they go into alarm. So if you have a place that you're testing and they're doing low-level testing, you need to understand that. You need to be able to show that you did make the sensors go into alarm, but you also need to be able to show that those alarms will in fact shut down the STP. So the simplest way to do that, of course, is to print these 3 reports again, actually 4. The status report we're always going to print, the sensor setup, the alarm history, but we're also going to add this output relay setup. So we'll look at the big long setup report. We're going to pull out this little part of it called the output relay setup and show that these alarms are connected to external relays, which are required by Veeder in order for you to be able to shut down the STP. You have to do that through an external relay. And you can connect that to like 8 of them in Veeder. So you do have these external relays in the system. They are set up. You see this one is connected to the Jet A sump. And so that's the way that you can verify that it is at least set up to shut down the STP. And so the last thing I'll mention, and I almost hesitate to do this, but you just need to be aware of this. If you're an owner operator in particular, this is for you. If you have a service provider that's doing your annual operability testing and you see them opening up the console on your tank gauge, again, this is the 350, on the right side or where the modules are and all the wires come in from the probes and the sensors. If you see them opening up the right side of your console, you kind of got to question, what are they up to? Well, why do you need to open this? They may have a perfectly legitimate reason for that. If they're troubleshooting or can't figure something out or want to verify something, but it could also be that they know this little trick, which a lot of guys know. This is not a secret. Lots of people know this about these root tank gauges. You can see the little modules there. The one at the bottom one, you look at the right picture, it says probe. That's obviously the tank gauging probe. The module above that where it says sensor, you see all these little wires going into. There's the black and the red, black and the red. These are 2-wire sensors. All these are 2-wire sensors, of course. These 208 sensors have 2 wires, positive and negative. And so the way that you can actually make them go into alarm without having to physically manipulate them outside or immerse them in water is to simply jump across the 2 little positive and negative terminals of each one of these sensors. If you short that, jump across there with that little wire right there, then it will go into alarm. And so the reason I bring this up again is there really is no reason for anybody to ever do this, except when you have a double-walled fiberglass tank. And the guy cannot get the sensor out. He may be tempted to just go into the console, find which one of these little 2-wire sets goes to the tank interstitial and jump across it and cause an alarm. And it will go into the alarm history. It will appear that he pulled the sensor and did the actual functionality test. And in fact, all he really did was jump across the positive and negative and cause it to go into alarm. So you just need to be aware of that. Hopefully that never happens to anybody, but lots of people know that trick. So the other part about probes and sensors, that's kind of missing from the EPA laundry list, if you will, is verifying that they are installed correctly. So RP 1200 requires you to verify proper installation as part of your functionality test. And you'd be amazed some of the ways these sensors are installed or not installed or just haphazardly thrown around, because all kinds of crazy stuff happens. Many times you'll see them just hanging by the wire itself, which is not unusual. They're not attempted to be mounted anywhere. There's no effort to really secure them in any way. They're just hanging by the wire or leaned up against something. That's very typical. The little hanger that comes on the standard 208 probe, it gets hung off a lot of different things. The pipe hanger really is used by a lot of guys to be able to pick the sensor up off the bottom of the sump and get it out of the water or whatever's caused it to be into alarm. Right? You see this all the time. So if you're an owner operator in particular, go out, look at your containment sumps and see where your sensors are. If they are not sitting at the bottom of the sump, and if they are not vertical, then they are not in compliance. So in an effort to try to make this better, we've had people do something like this, if you will. They will take some electrical conduit or something like that, and you'll see a lot of people put it in a piece of 1.5 or 2-inch PVC. And that's what you're seeing in these 2 pictures here, the one on the left and the middle. Piece of PVC pipe that's mounted to some J-channel, and the sensor is simply just dropped down into the pipe itself. They attempt to keep it vertical. The thing about this is, again, it's not hard to figure out. That you can look at the bottom left picture and you see what they did. There's water in the sump. So instead of the sensor sitting at the bottom of the sump again, you pick it up, take that wire hanger, bend it over the lip of the pipe that it's in, presto bingo, you're out of alarm, problem fixed, right? The guy in the top left right picture wasn't quite sophisticated. He did not have a pipe hanger on the 208 sensor, so he just simply picked it up out of the pipe and stood it up next to it on the lip of the manhole. Same thing with the one on the right. He just picked it up out of the pipe, set it on top of the manhole, get it up out of the water. So this really has been an ongoing issue for many years. It's nothing new here, and it will continue to be a battle that we have, is getting these sensors installed correctly and not having them tampered with. This picture, these two pictures here were just taken by me just a few weeks ago by the site I was at doing some testing. Brand new installation. Sorry, brand new place. And what the guy did is, you see that the PVC pipe is there for the float switch sensor to sit in. It was originally at the bottom of the sump. This actually was a leak. They had a leaking union in this brand new installation that no one caught. The service guy got called out. He went out. I guess he didn't feel like getting wet that day. He didn't want to fool with trying to fix the union that was leaking. So all he did was he took the communication cable, the wire, and just wrapped it around the electrical conduits so that he could pick up the sensor within that pipe high enough to get it out of the fuel and get it out of alarm. So sometimes you got to look a little closer. Sometimes it's not so obvious. You've got to look and make sure that that sensor is in fact sitting at the bottom of the sump. That's far more common than you think, that service providers do this a lot of times. And, you know, I guess it came as a shock to me that the guys that actually do this, but it's not that uncommon. They don't want to have to bother with trying to fix anything that day, maybe. I don't know, maybe they're in a bad mood, they're in a hurry to get somewhere else. They just fix it by picking it up out of the water, or in this case, the fuel. And the alarm goes away, everybody's happy, until the regulator shows up. And so the third thing that EPA says you got to do is, for annual operability testing, is vacuum pumps and pressure gauges. So there's virtually no one who does vacuum monitoring, interstitial monitoring, and that's what this is. This is a form of interstitial monitoring done with vacuum systems, or actually, I don't know anybody who does pressure, but if you're in California, you will see some of these vacuum monitoring systems. There's a few in North Carolina that I'm aware of, but almost nowhere else. And so really the only thing that we really do is say, okay, well, if you're doing this kind of monitoring, you need to make sure that the gauges are accurate. So that's really your operability test, is making sure that the gauge is functioning correctly. And I'll just mention this, and we're not going to spend any time on this. We don't have the time. It's not the purpose of today. But Mark wanted me to at least mention one of the tests that's been around forever and ever. We've always been required to do an annual automatic line leak detector test. This, amazingly enough, even after all these years, is very, very poorly understood by many people on how to do automatic line leak detector testing correctly. It's still done wrong all the time. But you know, with mechanical leak detectors, they've been around since the 1950s. Electronic leak detectors are a more recent invention, but we have to test both of them at least annually to make sure they are working correctly. And you know, the idea is you can test that 3 gallons per hour, 10 psi leak equivalent. Everybody knows that's the standard. That does not mean you can actually detect a leak of 3 gallons per hour, but it means you can see a hole in the pipe that is equivalent to the size of a hole that will allow 3 gallons per hour to leave if the line pressure were exactly 10 psi. So very common, even that simple concept causes a lot of people a lot of trouble understanding that it's not actually looking at a 3 gallon per hour leak in most cases. we're looking at a size of a hole. That's what the leak detector is capable of detecting, a certain size hole in the pipe. Part of the thing that was missing from the annual testing requirement that was made an important part of PEI RP 1200 is that you must confirm that the submersible turbine pump will cycle on and off correctly. That is part of the annual test. If you do not confirm that the pump is cycling on and off correctly, then you have not done a leak detector test. We'll just mention, that there are, with mechanicals, it depends on what the fuel is. So there are different models of mechanical leak detectors for different kinds of fuel. And with Franklin, they even have a leak detector made specifically for flex pipe or thermoplastic pipe. You just need to make sure that you've got the diesel leak detector in the diesel system and the gasoline leak detector in the gasoline system. One of the things that we see or still see a lot of is this in the old days, there were certain submersible pump manufacturers who did not build their pump manifolds, the pump head, the packer, whatever you want to call it. There was no place to install a leak detector in those old pump heads. Most of the ones that are left are Tokine, first generation Tokine STPs. There was no place to put a leak detector in. And so they came out with these special T's, these machined T's that have a signaling face on them. That's what you see in the right picture. The leak detector is actually installed in this T off to the side of the submersible pump. And so the piping that is to the left or upstream part of that T is not monitored by the mechanical leak detector. So if you had a leak in that union or one of those nipples or that 90 there, the leak detector is not capable of detecting that. And so for that reason, you cannot do that. You cannot have a leak detector installed outside of the submersible pump like this. Most states will allow you to put that special T immediately in the discharge of an STP, but you cannot have like that 90 and those nipples and that union between the STP and the leak detector. They simply cannot see any pipe upstream of the leak detector. If you have a scenario where you, for some reason, you cannot put the T in the immediate discharge, then you can just do electronic leak detectors. Of course, you could replace the pump itself, but electronic leak detectors can be put anywhere in the pipe, and it doesn't not matter if it's upstream or downstream of the submersible or the leak detector. The electronic leak detector is going to be able to monitor the entire pipe, both upstream and downstream. So in that case, it does not really matter where the electronic leak detector is. So again, with electronic leak detectors, you need to be able to show that you did in fact cause that electronic leak detector to go into alarm, that you did verify that it is capable of seeing a 3 gallon per hour leak. And so the way that you do that again, you need to be able to show tank gauging reports. And here's some examples again from Veeder. You look at the setup report for the PLLD, and you'll see that this one actually has 500 feet of fiberglass pipe, which is kind of unusual. You need to make sure, part of the annual functionality test, of course, is making sure that the setup is correct. Having 500 feet of fiberglass pipe is unusual at a typical gas station. Sure, it's possible, but you need to make sure that that is correct. The Veeder manuals will tell you that pipe has to be within like 10% of the actual length for it to be accurate. So you better have a pretty good idea of how far the distance is between the submersible and the location. Then you can see that this one, particular one, is only set up to do 3 gallons per hour, catastrophic leak detection. Or Veeder actually calls it gross. Veeder calls it 3 gallon per hour test, the gross test. So you see that the alarm history report shows that Q1, that's what the group calls a PLD, they call them Q. PLD1 was the premium. It did have a shutdown alarm. This unit set up to be shut down, by the way. But the gross line failure is what you want to see. That means it failed the 3 gallon per hour test. And there it is, of course, again, time and date stamp. And that should, of course, line up and agree with the date that you did the annual functionality test on the electronic leak detector. And I always like to do, again, just show me the last test result to prove that the leak detector is doing the 3 gallon per hour testing. And so there it is, of course, you just print that and make that part of the report also. And I'm going to tell you something, you know, if you've ever done functionality testing on PLLDs, it is not easy to do in some cases. In our experience, getting electronic line leak detectors to actually go into alarm when we have a 3 gallon per hour simulated leak, more times than not, it will not go into alarm. We cannot get them to go into alarm. There are a couple of different reasons for that. I'm not here to troubleshoot or pretend to be an expert on PLLDs, but it is very problematic to get an electronic leak detector to go into alarm sometimes. So it's very important for you to be able to show that you did cause it to go into alarm on the date that you did the functionality test. And again, there is the sensor alarm history, again, showing you that. And just reiterating, the dates should match, right? Yeah, they better match. The last thing that the EPA says is we do the handheld leak detection equipment. And this is nothing to this. If you happen to be doing groundwater or vapor monitoring, which virtually nobody does, then this would be verifying that your vapor meter is working correctly or calibrated, that your bailers are clear and not cracked, that you're doing manual inventory, that your stick is okay. That really is all there is to it. We'll try to get out of this, Mark.
Oh, great.
Not sure.
Yeah, that's
I'll
perfect.
read this again.
So yeah, thank you for doing that. That was great. We're hoping to bring in an outside perspective. You know, it's easy for us to show up and tell you what you need to do, but sometimes there's practical experience. So we got a few more minutes. We'll drop a survey in. Please feel free to answer. If you got any questions, Lauren, or we don't have to go the whole time, that's for sure.
Try to leave a little bit of time for questions.
May still be muted. No, let's take a look.
And it looks like the other Lauren might have gotten kicked off for a oh, she's coming back.
Gonna say I can help out.
Great.
Sorry about that. I got kicked out. All right, we do have questions. But since I got kicked out, I cannot see any of them. So somebody
can do
else
it,
will have to
Lauren.
take over.
I can do it.
Ingrid,
It's okay.
go ahead.
Okay, so first question, who do we report delay of required annual testing due to weather, etc.?
So I can try to answer that. So in that scenario, if testing was scheduled but unable to be completed, so for DEQ, there is no requirement to report that to DEQ that there was a delay. You are required to do your testing annually, so every 12 months. But for example, you know, you're in government camp, it starts snowing, you know, way early, beginning of September, whatever, right? Your service provider is unable to come at their scheduled date to do their testing. What I will be looking for as an inspector is that is documented along with that testing paperwork. So an easy way to do it might be, if the communication back and forth about when the testing was scheduled and needing to be rescheduled and why, if that's in an email, easy thing to do is print off that email and attach it to the testing results so that when the inspector shows up, they can see, okay, this is why the testing was delayed. If this was via phone conversations, in-person conversations, then I would be looking for the service provider to have documented that on their form. I would, for example, so October 1, receive call from operator to schedule testing, scheduled for December 1. On December 1, due to weather issues, was unable to come out to do testing, rescheduled to January 4th. January 4th, testing completed. Something like that. So because we are looking for that to happen every 12 months. If it didn't happen for an extenuating circumstance, we just want to see that documented, that there was that effort to have it done at the 12-month mark.
Okay, next question. I thought I heard you say we need the VEDA root on a battery backup. Is that correct?
I don't think, I mean, unless you know differently, Kevin, I don't think it needs to be, as if you have one, it needs to be tested. The idea is if there is a battery backup and something happens, you'll be able to fire back up. It's not required.
Great.
Unless you know different, Kevin.
No, I would agree with that. Yeah, some people make an argument that it has to be operated in accordance with the manufacturer's design standards. VEDA root says you got to have a battery backup, then you got to have it. But I'm not aware of anything they said that they have that says you have to have a battery backup.
Great. Anything else?
Yep, there's a few more questions here.
Great.
Since real testing and certifying overfill protection via ball flapper valves and ball floats requires filling tanks to 95% or 90%, and they aren't tested pre or post install, are they going to be outlawed? Visual inspection can only prove the protection. I have pulled half stick out of fill necks left by delivery personnel to overfill tanks. Audible alarm seems to be the only testable option.
So yeah, I can answer that a little bit, and please pipe in, Kevin. So here in Oregon, if you ball floats are allowed on older systems, meaning if you install a new tank after 2018, you can't install a ball float. Let's say you have a ball float that was installed in the 70s, 80s, 90s, and it's operation, you can still use it. And the same thing with flappers. When you install a new facility, your two options now are put into overflow flappers or the overfill alarm. So let's say you're testing your flapper or your ball float. We're not asking you to fill that to 95%. And we're getting a little off topic, so I'm going to be really quick here. So if you're confused about this, please reach out to me. What the purpose of that testing is just to verify, as an example, that the ball float is set at the appropriate measurement or the flapper set at 95%. And we also want to verify that that flapper moves up and down. Like you just pull, you remove the drop tube and you lift the flapper to make sure it works. And the same thing with the ball float. We want to make sure the cage is still there. And then there's the balls in there and it moves. We will talk about this at a different time. I don't want to get into the details here, but you do not have to fill the tank to 95%. We're testing to make sure the equipment just operates. That doesn't mean it's going to operate with the fuel. It's just that it's not, stuff isn't blocked up. It's I'm not a tester. I don't know if Kevin can expand on that a little bit.
No, that's exactly right. The thing I might add though, if you follow RP 1200 and you're looking at flapper valve, for instance, of course you pull the flapper and you measure everything and verify that it's set at the correct level. But part of that annual operability test is, of course, you're verifying that there is no obstruction in the drop tube that would prevent it from working correctly, or the same with the ball float valve. You're verifying that all of the fittings on the top of the tank appear to be vapor tight. And if there's something obviously wrong, then you're going to fail that overfill device, even though it may measure correctly in the tank. So it's not just a straight measurement. It's a visual. Sure, there is just no way. We have a lot of talk about this. There is no way to safely require someone to intentionally overfill a tank. You just simply cannot do that. And so the only thing you can do is verify the correct measurements and everything appears to be correct. then that's what we do.
Perfect. Thank you.
Great. Okay, there's a few more questions here. So if we have upgraded tanks and lines after 2018, we no longer need to do an independent tightness test on lines.
So you're getting into the minutia there. So for any tank installed after 2018, sorry, that's actually after 2008. I apologize. We would call it new piping. You are required to do interstitial monitoring of that piping. And so you'd have a sensor in your tank top sump, and you want to make sure that that sensor works. And if you're doing that interstitial monitoring, you do not have to do line testing. You still have to test the leak detector, just not line testing. Again, if you need more clarification, contact me after. It's definitely a it's getting deeper in the weeds, and there's some confusion there. There's some facilities out there that were installed, a few years ago, let's say, and they're still doing line testing because they just don't know better, and you could save a few dollars on your testers. Please reach out to us, and hopefully I can communicate that a little better. So,
Thanks, Mark. Okay, another question. We have a pneumaticator system on an emergency generator. Our tester is saying we have to upgrade the system due to the age. Is there any requirements from DEQ to upgrade the system?
Unless the other team members think no, as long as it's third-party certified, which I'm pretty sure pneumatigators are still third-party certified. And if it's operating properly, I understand there's not going to be a printer, but if it's still being tested and it still operates, nope, there's no requirement to upgrade. We just want to make sure it's third-party certified. And again, I can help you with that. You got to go to their website and look. Kevin, have you heard anything? Those are still third-party certified, correct?
I can probably guess why the service provider is telling them that. And because it's probably like me, that pneumatigators are so bizarre that he doesn't know how to work it, doesn't know how to operate it. They're just bizarre. I hate pneumatigators.
There you go. But no, we don't require you to remove it. If it's working and third-party certified, nope, you can still use it.
Okay, great. All right, two more questions to go. With the TLS 300 and TLS 350 being phased out, how much different is there going to be with the TLS 400 series? And this is the VEDA route.
Yeah, that's
a good question.
Yeah, we see 450s. The equipment, that's a better question for VEDA route, but the equipment is generally the same, right? You're still gonna have a tank probe and a tank gauge. However, the tank gauges are more complicated. They're touchscreen. It's still the same testing. So I don't know if Kevin, how much experience you have with it. But.
Yeah, it's kind of the same deal. 450s are kind of, once you get the hang of them, the 450 plus is much better than the original 450, but navigating through all those touch screens and getting the right reports out of them can be challenging. But they are there. There are acceptable substitutes, if you will, for what everybody is familiar with, the old 350 reports. They're not exactly the same reports, but yes, they are there. You can find them. It's just more difficult because you're just not familiar with them.
Yeah. All right, I guess we have one more question and then we can let you all go.
Okay, here we go. Sorry if this has already been covered. Is there a form that needs to be completed each month at the station level?
Well, I didn't talk about it. It's called a monthly walkthrough, and we can help you with that. We don't have a form. We did have a form. We took it off. We're putting a new one on there, and it's a very simple form. You want to check the tank leak detection, check the spill buckets. I mean, that's what the rules state. We hopefully will get a form up shortly. There's I don't think EPA has a form, but we can help you with that for sure. So that is one of the requirements. So anyway, we're getting, I don't know if do we have any more questions? Or?
Nope, that's it. They've all been answered. I was just double checking the other side to make sure, but looks like we're good to go unless somebody else has a final question they want to type in.
Or we can all. Great. Well, thanks, Kevin. I hope you all enjoyed this. If you want to see this in the future, please let us know. I dropped a survey in the chat. Hopefully it's a few seconds and we can go on our days. Thank you for participating. I really hope this is helpful. And if you have any questions, please let me know. So thank you.
Thank you all.
Everyone.
All right. Thanks. Hopefully we'll be ending this recording. Thanks, Kevin. I'll be in touch.
Yeah, man. Thank you, sir. Appreciate it.